Hello, welcome to this channel. In this video, we are going to discuss about DFS. DFS stands for Depth First Search. It is another graph traversal algorithm used to explore and traverse a graph. Similar to BFS, DFS visits all the vertices in the graph, but it does so in a depthward manner, exploring as far as possible along each branch before backtracking. In DFS, the algorithm starts at the specified source vertex and explores as deeply as possible along each branch before backtracking. It moves to an adjacent unvisited vertex, visits it, and recursively continues the process until it reaches the vertex with no unvisited neighbors. At that point, it backtracks to the nearest unvisited vertex and continues the exploration until all the vertices have been visited. DFS can be implemented using either a recursive approach or an iterative approach using a stacked data structure to keep track of vertices. DFS has its own set of characteristics and application. Characteristics of DFS is it explores a single branch as deeply as possible before backtracking. It uses a stack, either explicit or implicit, to keep track of vertices to visit. It may not necessarily visit all the vertices in a connected graph depending on the starting vertex and graph structure. It is often implemented using recursion. The application of DFS: determining the connectivity. DFS can be used to determine if a graph is connected or if there are multiple connected components. DFS can be employed to detect cycles in a graph by keeping track of visited vertices and identifying back edges. DFS can be used to perform topological sorting of directed acyclic graph. In directed graph, DFS can be used to find strongly connected components. DFS can be used to navigate and solve mazes, finding paths from a starting point to goal. DFS is the versatile algorithm with its own set of strengths and application. Understanding its depthward exploration strategy and its implementation variation can be valuable in solving graph-related problems. I hope this lecture has provided you with a clear understanding of DFS, its characteristics, and its application. Thank you for joining me in this lecture. If you found this video informative, please consider liking and subscribing to my channel. Your support motivates me to create more educational content like this. If you have any question or would like to suggest topics for future lecture, please feel free to leave comment below. I value your feedback and ideas.